All right, welcome. Today we are pulling back the curtain on AI agents. We're going to look at three critical puzzles that researchers are cracking right now to build what's next. So let's dive right in. When you see an AI agent do something incredibly complex, it really does feel like magic, doesn't it? Like it's this little thinking black box. But what's really going on in there? How does it actually reason? And maybe more importantly, how can we trust it? And how do we make sure it's not so expensive that nobody can use it? Well, it turns out the path forward really comes down to solving three core challenges. We're calling them the 3 C's: cognition, contracts, and compression. And once you get these, it's kind of like you're getting a sneak peek at the blueprint for the AI of tomorrow. First up, let's talk about cognition. We really need to challenge this popular idea that large language models, LLMs, are these conscious thinking beings. The truth, according to some fascinating new theories, is actually way cooler. So, one brilliant new theory basically reframes the whole thing. It says an LLM isn't a brain, it's an unconscious pattern repository. Okay, what does that mean? Just picture a colossal, dark library that holds nearly every pattern of human knowledge. The intelligence isn't in the library itself. The books aren't reading themselves. It only lights up when you walk in with a flashlight, which is your prompt, and illuminate the right section. So yeah, the old way of thinking was contained intelligence, this classic sci-fi idea of a thinking brain in a box. The new model, though, is activated intelligence. The LLM doesn't just sit there and think. No, our prompts, the context we give it, they act like anchors. They activate just the right patterns from that giant, dark library to build an answer. The reasoning that we see is just what emerges from that process. And this isn't just a theory. A framework called Collaborative Chain of Agents, or COCO for short, shows exactly how this works. So first, an agent acts like a librarian. It goes out and finds fresh, up-to-date knowledge from the web or a database. Then, it uses that new info to light up the right spots in the LLM's huge internal library. And finally, the system blends both of those sources together to create a response that's way more accurate and aware of the context. See? It's not magic, it's just a really smart, structured process. Okay, but this leads us right to the next big problem, and our second C. Contracts. Because even if you have this amazing pattern matching machine, what good is it if you can't rely on it? I mean, for really important jobs, you can't have an AI that's just winging it. You need guarantees. You've got to have trust. This whole shift in thinking is captured by this really powerful little phrase: blueprint first, model second. Instead of just letting the LLM figure out how to solve a problem on its own every single time, you start by defining a strict, reliable procedure, a blueprint. So the key here is putting a framework in place called design by contract. I love this analogy. Think about your powerful LLM as a brilliant but kinda erratic intern. You know the type. They can do incredible, creative work, but would you let them run a critical, multi-step process without a super detailed checklist? No way. Well, a contract is that checklist. It's a set of strict, ironclad rules that controls what goes in and what comes out, making sure it always stays on track. And this really shows the fundamental change. Most models today use a probabilistic workflow. They kind of wander towards an answer, and because it's non-deterministic, you might get a different result every time. The blueprint first idea, though, creates a deterministic workflow. The main logic is controlled by solid code, not the whimsical model. The LLM is only called in for very specific controlled tasks, and that makes the whole process predictable, checkable, and something you can actually trust. Okay, so our agent is smarter, it's more reliable. We're done, right? Not so fast. There's another huge problem: the cost. And that brings us to our third and final C, compression. Because all that complex reasoning that makes these agents so powerful, well, it also makes them incredibly expensive and slow. There's this technique called chain of thought, where you ask the LLM to think out loud and show its work. And it's great for getting accurate answers to tough problems. But here's the thing. That thought process is usually super long-winded and filled with stuff that just doesn't matter. It's really like a messy first draft that's screaming for a good editor. So just how much of it is redundant? You won't believe this. The research is stunning. It's 80%. An unbelievable 80% of the reasoning steps can be just thrown out with almost zero impact on the final answer. That is a massive, massive amount of wasted time and money. So how do you edit this down without breaking it? Well, if you use the full unedited chain of thought, you get high accuracy, but it costs a fortune. If you just start chopping out steps randomly, your accuracy goes right out the window. But here's the breakthrough. A method called entropy pruning. It's smart. It can tell which steps are just fluff and which are important, and it only removes the redundant ones. So you get the best of both worlds. You keep that high accuracy, but you slash the cost. And this isn't just a fun idea for a lab. This has real-world impact. Research into making agents more efficient shows that by using these smart designs, they took the cost of one common task from almost 40 cents all the way down to under 23 cents. That's a huge saving, and it's what's going to make these amazing tools available to everyone. So let's zoom out and put all these pieces back together. Cognition, contracts, and compression, they're not just separate ideas. They're interlocking parts of a brand new blueprint for how we're going to build AI agents from now on. So let's just recap that new blueprint. First, cognition. We stop thinking about a brain in a box, and we start activating patterns in these huge knowledge libraries. Second, contracts. We make AI trustworthy and reliable by giving it a strict, code-based blueprint to follow. And third, compression. We make it affordable and fast by cutting out all the redundant thinking. These 3 C's, they give us agents that are powerful, reliable, and efficient. And that brings us to one last big question. As we get better and better at building these agents, making them so predictable, so reliable, so efficient, what are we actually building here? Is this the blueprint for just a better, fancier tool? Or by giving it a structured role, predictable behavior, and efficient ways of working, are we in fact designing our future colleague? Something to think about.